Hi, today I will show you how I used Microsoft's machine learning library to train and then detect spam emails. A few years ago, I developed an application that uses some heuristics to detect viruses in emails as well as spam. I explain this over here. However, over the time, I started getting a lot of spam emails, and those heuristics that I used, those rules that I used, were not enough. So I decided to try Microsoft machine learning library to train model and then based on that model predict whether incoming email is a spam or not. Application that relies on machine learning will be called by my old application in cases when heuristics did not confirm that email is a spam or virus. Here is the code for old application. In case it did not, the rules did not result in spam or virus detection, it will call a new application. And here is the configuration for old application. There are a few settings added, and this is code for new one. As this new application relies on previously trained model, code for spam detection in emails is not complicated. It basically loads that model from the disk, and then using that model predicts whether the email is a spam or not. The challenge is not to use trained model, but to find and prepare a proper data set to train a model. I first took this email data set from web, and it did have a few thousands of emails, some labeled as spam, some labeled as not being spam, so-called ham, and it did result with a model, this one. However, when I tried it, I wasn't satisfied with results. Simply some emails were not properly detected. Then I decided to train a model based on my own emails that I was getting over the years, and I took a few hundreds of them. Challenge is to properly label your own emails as spam or not being spam, because we are talking about a few hundreds of emails here. However, you can use shortcuts to do that. There is a rule that whenever you responded to an email, most probably it wasn't a spam. So I took all email addresses to which I responded, and I mark emails of those people as not being spam. Because this program works with EML files, those are standard file types for emails. You need to export your past emails into a folder. I use this one here, and you can do this if you're using Thunderbird. You can there is an option to export selected emails into a folder, and they will be saved as EML files. Now, as I said, you need to label those emails as spam or not spam. So you can also export all emails that you responded to in order to mark them as not being spam. In Thunderbird, you can take your address book, go to collected addresses, and over there you can export comma-separated value of those addresses. So those people were definitely not spammers. And then it will help you move all your exported emails to either ham or spam folder. Another rule that you can use besides addresses of people to whom you responded is to over time collect some spam phrases, like luxury watch or get rich quick, and then just search all emails to find which one contains those phrases. Of course, I did not do this manually. I wrote some routines to do this work automatically or semi-automatically, and you could use them as well. And in the end, I ended up in emails being either in ham or spam. Here is the those routines that help me prepare my emails for training. There are steps, and in an ideal world, you would make a process pipeline from those steps, so you can run them in one click and do model training multiple times until with some adjustments until you're satisfied with the results. Here is the method that is doing actual training. When I ran it against around 1,500 emails, it took less than 10 minutes. It resulted with a zip file which I saved to disk. This line here is doing the actual training of the model. The important thing is to choose the right training algorithm here, and for this case it wasn't a big challenge because as we are working with label data for which we knew whether it was a spam or ham, and that's why we are working here with supervised learning, and as we are expecting for results to be in one of categories. In this case we have two categories. We are talking about classification here, and that's why I took binary classification. I could experiment more with different algorithms comparing their results. However, I was satisfied with the result I get from this one. Usually the practice is to take your data set and then set a percentage of those items that will be used for testing. Sometimes it is like 15% of the total data set, and then automate the whole process and measure the results. However, as I said, I just used my trained model, and later over the next few days I was getting proper results, expected behavior from this application. And here is the model that I got by training it on my own emails. However, I did not include this model with the source code because it does contain some personal information. So I included models trained on this data set. So be aware of the license. And as you can see, every such model contains some personal information. For example, in this vocabulary file, there are some emails there. So those methods that will help me prepare my emails are implemented as test cases. So you can simply run them in Visual Studio by each one by one, as well as training the model itself. However, as I said, you could automate this process and create pipelines for those processes. And here is the execution. I have one simple spam email that I'm using. Note that I specified that sample spam email in debug options. So when you run this application, it will target that file. Basically, I told him to check this file. And you could see the log for the execution. It tried using some heuristics. However, it had to call our new application, and it was loading model from the disk and predicting whether it is spam or not. And it saved that spam in our virus folder. One thing to be careful about is to train your model on the data set of emails which are all in the same format. For that purpose, I wrote some routines to strip out HTML from my emails, practically to simplify all my emails, and they look something like this. Every email on which I was doing training, I have basic header information with pure textual content of email. As you can see, it's not perfect. There are still some HTML tags, and in future I could strip them out as well. But important thing is that all my emails are pre-formatted before being put into a dataset for training. To give you a little bit info about the solution structure, all the magic happens here. So the training and prediction is implemented in engine project. This spam mail detector is just a console application as a shell for calling the engine. You specify practically a single parameter attached to the EML file, and it will output either 1 or 0 depending on the result. And as I said, this old application is calling that new application. This library here is a library with some helper methods. I explained that library earlier. This Foodie Weavers is a gadget that I included in every project because it was compiled to produce smaller numbers of DLLs in outputs.